Hello everyone, today in this video we'll be discussing the first module of DDCO super important questions, and in this module we have 7 questions. I have 8 questions which are the most repeated and the important ones from the model paper and previous scheme papers, the previous question papers of the same scheme. All those questions I have analyzed and took up some 8 questions which are the most important ones, and if you watch this video till the end, easily you can score more than 80% marks in the exam. And before starting, please do like and subscribe, it helps me make more videos like this. And without wasting any more time, let's get started. The first question is write a program in Verilog to demonstrate the working of user-defined primitive table. Okay, we have to write a program in Verilog to determine the working of user-defined primitive table. Okay, they can ask you the question even like the rules of UDP table. Okay, so in this case, what is to be done? So let's understand the rules of UDP table. Okay, so the UDP table is declared with a keyword primitive followed by a name and a port list. Okay, first we have the word primitive, then we have a name, and then we have a port list. Okay, an example I will show, then you will get get it clearly. For now, let's go through the rules. There can be only one output. Okay, only one output will be there. Only one output will be there. There can be any number of inputs. Okay, the truth table is enclosed within the keyword table and end table. So within table and end table, the whole truth table will come. Okay, we'll be writing the truth table as well. Inputs are listed in the order ending with colon, so inputs are separated with colon, and the output is always followed by semicolon. Okay, so at the end there will be colon for input, and for the output there will be a semicolon. Declaration of UDP ends with the keyword primitive, and at the end we will be writing primitive. Okay, so when the UDP program ends, so let's understand this by an example. See, first we will be writing this comment, verilog model user defined primitive. This is just a comment. So after that primitive we have written, and we are writing the function name and the input parameters which we are accepting. The output is present here, the input is present here, the truth table is also given here, and we'll be having the keys here, different keys A, B, C, and D. This is the output, these three are the inputs. So for this is the truth table. Okay, so for the truth table starts with table. Here you can add 0 0 0 0 0 1 0 1 0, the same sequence. Okay, you can write, and here also you can fill with 1 or zeros. Okay, and see, the input is ending with 0, and this is ending with semicolon. The output is ending with semicolon. Okay, after that truth table is over, we will be writing end table, and with that we'll be concluding the end primitive keyword also here. Okay, and for the circuit, what we'll be writing is the model, then circuit with UDP. So here we'll be writing the inputs. Here we have ABCD, and here we have E and F also. So output is for EF and input is ABCD, and here we'll be writing UDP 02467 EABC, and here FED. Okay, means the output is associated with F and E, and input is associated with E only. Okay, option gate is instance, name is omitted. At the end we will be writing end module. Okay, so this is the thing which you need to write, the truth table and the verilog model also. Okay, moving on to the second super important question, which is F is equal to AB plus CD. We have to realize it using NAND gates only. So whenever this question comes, okay, whenever we have to realize it using NAND gates, all you have to do is you have to just put a double not on the top. Okay, so double not will be equivalent to the nothing here, right? So double not, if we apply the Boolean algebra laws, we will be able to expand it. When we expand it here, what we'll be getting is AB not and CD not. Okay, so when this two is being not here, and that also has another not here, so the first NAND gate will be here for this one. This is the first NAND gate, second NAND gate will be for CD, and the third NAND gate will be for the combination of these two. Okay, this is the third NAND gate. So this is how we realize F is equal to AB plus CD using NAND gates only. So this is valid for every question. Okay, moving on to the third super important question, simplify the Boolean expression using K-map. Okay, K-map is never to be missed. Okay, you have to never miss K-map. Okay, it's a very very important question. Almost in all the papers, K-map has come. Okay, so this is the most important topic in this whole subject also. Okay, so we have been given two a Boolean expression. Okay, and here we have been given a sigma sign. Sigma sign means it is in SOP. Okay, so mostly they'll be giving sigma sign only. If they give in pi sign, that will be equal to pos. Okay, so most of the time they'll give SOP only. So in case even if they give as pos, okay, how do you convert it into SOP? Usually take this one. Okay, usually take SOP, this will be easier. Okay, so suppose that they give you in the pos form, like 2 4 6 5, like that they have given. How do you convert it into the equivalent SOP? You observe which numbers are present in that. Okay, whichever they had given here, which numbers are present, and which numbers are not present, that will be equivalent to SOP here. Like for example, if you are considering till 15 here, okay, See here, here they have given till 15, so 4 inputs means till 15 it will be there. So in 15 I have in the SOP, I mean the POS which they had given, there was 2, 4 and 6. Okay, so what will be the remaining numbers in SOP which will be coming? It will be 0, 1, 3, 5, 7, 8, 9, 10, 11, 12, 13, 14 till 15. So all those numbers which are not present in the POS will come in SOP. Okay, so if they give you in POS, they convert it into SOP and then continue, or else you can continue with POS also, but I'll be explaining with respect to this. Okay, so see here, ABCD they have given in the question in SOP only. So let's continue. After this, what you have to do is you have to draw a table like this. Okay, like this a table needs to be drawn. Okay, after you have drawn a 2D table, you'll be writing here 0 0 0 1 1 1 1 0. Okay, here you observe carefully, after 0 1 you have to write 1 1, not 1 0. Okay, because this is gray code. Gray code means only one digit should change. In these two numbers only this digit has changed, and in these two numbers also only one digit should change. In these two numbers also only one digit should change. So if you write 1 0 after this one, we'll be changing two digits. 0 will turn 1, 1 will turn 0. That is not valid. Okay, so only 1 1 should digit should change. So this also will be 0 0 0 1 1 1 and 1 0. Got it? After that, what I have to do is whichever numbers which they have given here, I associated with that. Okay, 0 0 0 0, which is that number? 0 0 0 0, it is corresponding to 0. 0 0 0 1, that is corresponding to 1. 0 0 1 1, that is corresponding to 4. Right? 0 0 1 1 is corresponding to 4. 0 0 1 0, it is corresponding to 3. So based on that, you will be writing here 0 1 2 3 like that. Okay, 0 0 1 1 is 3, not 4. Okay, it is 3. So you'll be writing those numbers here: 0 1 2 3 4 5 6 7 8. 8 will come here, 9 10 11 12 13 14 15. So in this case it will be like this. Okay, so since I have done this question previously, I know where all the numbers will come. Okay, but if you also calculate it and write like 0 1 0 1, that is equivalent to, what is 0 1 0 1? It is equivalent to 5. Okay, like that also you can do. After you have written the numbers, anyway you have to fill it with those numbers. Whichever numbers have been given here, put that as 1. 0 is given, I'll put as 1. 1 is given, this is corresponding to 1, I'll put as 1. 3 is given, corresponding to 3, this is 3, I'll put as 1. Like that for all the numbers I have to put here. Okay, after that you have to make groups. Okay, groups will be formed in the basis of 2, 4 or 8. Okay, or a single. So you have to try to form maximum group. Okay, if 8 is possible, you have to try to form 8. If 8 is not possible, check for 4. If 4 is not possible, check for 2. 2 is not possible, make it as a single one. Okay, so see here what we will be doing is, here 4 is possible. Okay, first let's take an easy one. Okay, and it's not necessary that you make the groups as only as how I have made. Okay, you can make it in other ways also. There are other ways also possible. See, I could have taken this one. Okay, I could have taken as this one, but I have taken this one and this one together. Okay, so you can take it anyway, that all are valid. Okay, so see, first make a group. This two will be forming a group, another two is here, form a group here also like this. And after that you can see I can form another two group also here, and another two group also here. I can do it like that, but I have to form the maximum group. So if you observe carefully, I can take this as up and take this from down. Okay, if you observe this as a circular paper, this end will be connected with here, right? So in that way, this also you can take. Okay, this also as 4 as one group also you can take. Okay, so we have taken this as a 4 group because I want the maximum one. I can take this 2 and 2 also individually, but that will not be the simplified equation. Here we have to find the simplified one. For simplified, we have to take it like this one and this one. This will form one group, 4 in one group. Another one I can take is this one from here and this one from here, but this one is already taken, but I can use that already taken one also, given that another new one should be present here. That is valid for the 4 ones also. Okay, so I cannot take this one. Okay, this group I cannot take because this one is also already taken, this one is also already taken, right? Both, this one is already taken in this group, this one is taken in this group. If both are taken, I cannot form a group in between. In this case, this was not taken, this was taken. Even if one of them is not taken, I can form the whole group. Okay, that's the rule. Now, since we have understood the rules, we'll be writing the numbers here. Okay, so 4 groups are formed. The group 1 is this. Okay, this is the group 1. Okay, this is the group 2. This is the group 3. This is the group 4. Okay, now I'll be writing ABCD. After that, 0 0 0 0 corresponding to this 0 0 0 0 that I'll be writing. Next is in this group 0 0 0 1, so I'll be writing here 0 0 0 1. Next after that it in this group is 1 0 0 0, so 1 0 0 0. After that is this 1 0 0 1 1 0 0 1. After I've written this one, do it for the other groups also. This one is 0 0 1 1. Okay, 0 0 1 1 is corresponding to this one 0 0 1 1, and 0 1 1 1 0 1 1 1 is corresponding to this one. So this is another group, this is the second group. In third group you have 1 1 0 1. Okay, 1 1 0 1, this is 1 1 0 1, and this is 1 1 1 1, so 1 1 1 1. The last group is this one 1 0 0 0 for this one, 1 0 0 0 for this one, and 1 0 1 0 for this one, 1 0 1 0 for this one. Okay, so I'll be writing the four groups here. Now how I have written these numbers, these letters here. For these letters what you have to do, see here, observe carefully, this is 0, this is 0, this is 1 1. It is changed. Okay, it is not same number here in the whole column. In this column it's the same number, so I'll be writing it as b naught. If it is 0 I'll be putting a bar on top, if it is 1 I'll not be putting any bar. Okay, that's the rule. So here b's are having all zeros, so since 0 is there I'll write b and put a bar. C is same, so I'll be writing c, and 0 is there, so I'll be writing a bar here. Okay, and d is changing, so I'll not consider d. In this case a bar, b is changed, c I'll be writing it as such, d also I'll be writing it as such because 1 is there. A, I'll be writing it as such. B, I'll be writing it as such. C is chain, will not consider. D, I'll be writing it as such. Here, A, I'll write as such. B, I'll put a bar. C, I'll not take. D, I'll put a bar. Okay. So after that, you'll be just writing F is equal to B bar C bar plus A bar CD plus ABD plus A bar B bar D. Okay, like that you'll be writing F value. Got my point? Okay. So like this, you'll be forming a group. Now, this is the final SOP equation. This is the final SOP equation for this one. Okay, so this is the SOP which they have given. Now another question, similar question, WXYZ, and the numbers are given here. Okay, now you tell me one by one what is to be done. First thing, we'll be writing WXYZ here, making a 4x4 table. 0 0 0 1 1 1 1 0, again 0 0 0 1 1 1 1 0. After that, wherever the numbers which they had given, which are the numbers 0 1 2 4 5 6 7 10 15, all these places I'll put 1. I'll make groups. The 4 can form a group here, another 4 can form a group here, and 2 can form a group here, and another 2 can form a group here. Okay, done. After that, I'll be taking each group one by one. Let's take this group one by one. I'll be writing those numbers here. For each of these, I'll be writing what are the combinations of this one and this one. I'll be writing here. I'll do that for the other groups also. All the groups I will do. After you're done for all the groups, just see which is not changing. W is not changing and it has a 0. So W bar. X has changed. Y is not changing. So Y bar. Z. Then here W bar X. Yeah, W bar X. And here we have no W is changed. XYZ. So it will be XYZ changed, same, so it will be X bar YZ bar. Okay, after that we'll be writing F is equal to the combination of all of these. Okay, so this is the final answer. Okay, next question is simplify the following Boolean function into SOP and POS. Okay, we have to convert it into sum of products and product of sums. So this is the function given to us, and this is the don't care conditions. Okay, so this is the D means don't care conditions. So don't care condition means we can put there 1 or put 0 also based on our own requirement. If 0 makes more simplified version, we can use 0, else we can use 1 also. So SOP will be doing first, we'll be writing these numbers which are present here, marking them as 1, and the marking 2 4 and 10 as X here. Okay, now in our case we will be taking X as 1 because in SOP we have to take the groups of 1, right? So when we do that, as you can see, different colors different groups form. Okay, different colors different groups form, and in each of these group we will be having the simplifications based on the same ones or different ones. Okay, based on that we'll be getting the values which you can see here, and we'll be getting the SOP form. Okay, this is same as the previous one which I discussed. So the color mapping is also there. You can easily get to know how it is different. Okay, solve this same question once by yourself and compare the answer. Okay, in POS it is different. In POS what we will be doing is we'll be marking those values which are 0 here. except 1 and x, all other blocks which are present here, that should be marked with 0. Okay, for POS we have to do that, product of sum, and for 0 we have to form a group. So one group will be here, this is one group, and this is one group which is coming like this, and x also we can take it as 0, we can form another group here, and these 4 zeros we can form another group. Now this x and x is also present here, I can form this group as well, but both x we should not form a group, that will make the equation unsimplified. Okay, to get the best simplification we have to not use only x. If and suppose 0 is there, then we will use these two. Okay, then we'll use it like this, but in the case only when x is there, forming a group will be uh, lost for us. Okay, so we have to not form the group, so we'll be having 4 groups here. Okay, based on these 4 groups we'll be simplifying, and when we get the answer, see, one thing you need to observe here is, after that in POS what we'll be doing, suppose this is same here. Okay, this is same here and it is 0. As I told you, if it is 0 we have to put bar, right? 0 means a bar, but in POS we'll not put a bar. Okay, that's the reverse thing. If it is all ones, then only we'll put a bar. Okay, it is reverse as the previous one, and instead of multiplication we'll be putting plus here. Okay, so see, this is not common here, this is common, so it will be b bar, and c plus d. Okay, so c and d will be as such, and plus will be there in between. Like that we have to form for all the 4, and we'll have to write it in this form, product of sums. See, this is a product, right? Product of what? Sums. Got my point? Okay, moving on to the fifth super important question, define prime implicant and essential prime implicant, give an example. So this is the definition. A prime implicant is a product term obtained by combining the maximum possible number of adjacent squares in the map. Okay, by getting the maximum number of squares in a map, if we make a square like this, that is called as prime implicant. Okay, essential prime implicant is a prime implicant that covers at least one minterm that no other prime implicant covers. What does this mean? See, in this diagram I can form 3 prime implicants, 1, 2 and 3. See, 3 is this because here it can be formed, but it is already this one is with this group, this one is with this group, but still we can form a prime implicant here, but it will not form essential prime implicant. So number of prime implicants will be 3, which is this one and this one. So in prime implicant it doesn't matter if it is already covered by other terms, still if it is possible it will be a prime implicant. Essential prime implicant will be 2, because this one is one and this one is another one. This one cannot form because both of the numbers are already taken. Okay, that is the difference between prime and essential prime implicant. We got a sixth super important question. With an example, explain the working of test bench in verilog. Okay, what is test bench? Test bench is used to simulate the design without the need of any physical hardware. Okay, we have to test if the circuit is working fine or not. So to test that circuit, instead of having actual hardware with the wires and all, we can simulate it using a software that is called as test bench. So before simulation, the test bench needs to be written. What do we need to test? That we need to write. Okay, so this is the design code. An example: module, half adder, A, B, sum, carry. Okay, this is the code for half adder. So input is A, B, output is sum and carry is equal to A and B, and operation is in carry, and the XOR operation is in sum, and then end module. Test bench code. Okay, module, half adder, TB. Here AB are the regular REG, we have to write register AB, and wire, sum and carry are the wires. Okay, because the output goes through them, and half adder dot a dot b dot sum dot carry. Okay, now here nothing is there. Here what is there is, if a is 1 and b is 0, b is 1 and b1. If a is 1 and b1, then b is 1, b0, like that. Different combinations are there based on if a, what is the a value. If a is 0 and b is equal to 1, what will be the sum, what will be the carry. Okay, that values only are given here, so you have to just write it like this, and end module. Okay, don't try to by heart this one. You can just write whatever you feel. Even if it is not correct, you'll be getting marks. Okay, so that's all about the test bench code. Moving on, we have the seventh super important question. Reduce the following Boolean expressions to minimum number of literals. Okay, so you have to use Boolean algebra for this one. So let's start with the first one. X into x bar plus y. So when we multiply x into x bar, what is that? X into x bar is equal to 0. Why? Because if x is 0, x bar will be 1. If x is 1, x bar will be 0. So 1 into 0 and 0 into 1 both are 0 only. So we'll be writing as 0. Xy will be as such. So 0 plus xy, 0 or xy is xy only, right? So whatever the value of xy is, if it is 0, 0 plus 0 is equal to 0. And if it is 1, 0 or 1 is equal to 1. Okay, this you have to refer to the basic truth table for or and not. Okay, basic table. So you can refer the module 1 video of DDCO. Okay, you can find the link in the description box of the playlist. There you can watch module 1 of DDCO. Okay. Next one is x into x plus x bar y. Okay, so here you know this rule, right? See, if it is like 6 into x plus y, what we can write it? We can write it 6x plus 6y. Like that only. If it is like this, 6 plus xy, I can write it as 6 plus x into 6 plus y. Okay, this is called as distributive law. So based on that, x plus x dash y, so I can write it as x plus x dash into x plus y. So x plus x dash, it will be equal to 1 based on the OR rule. Okay, in the OR rule, if this is 0, this will become 1. If this is 1, this will become 0, and either of 0 or 1 in both cases will be 1 only. So 1 and this, okay, 1 and this, it will be this value only, right? 1 or x is equal to x. Okay, this is another law. So we'll be getting x plus y only based on this. Okay, next we have x plus y dash. Just take x as common. When you take x as common, you'll be getting plus y dash. Y dash is 0, so the answer will be x here. Xy plus x dash z plus yz. Okay, now what we are doing, we are multiplying xy with x dash z. So it will be xy plus x bar. Okay, xy plus x bar plus xyz. Okay, xy x bar plus xyz. Just multiply xy with this one and multiply xy with z. Then put an add in between. Okay, so you'll get these two terms. In this term, x bar is there, x is there, so it will cancel out each other. It will become 0. Cancel out in the sense x into x bar is 0, right? And 0 into y is equal to again 0. So like that 0. Okay. Xyz and yz, take yz common, you will getting x plus 1. What is x plus 1? X plus 1 is always 1, whether the value of x is 1 or 0, it will be always 1 here because OR operation. So yz will be the final answer. The laws use are distributive and identity law. In the same way, we will simplify this also. First we will multiply this term with this term. How we will do that? X into x bar plus x into z plus y into x bar plus y into z, and that whole answer multiplied with y plus z. Okay, so this whole answer multiplied with y plus z. So we'll be multiplying y plus z now. So when we simplify this value, okay, when you simplify this value and multiply with y, okay, when you simplify this value, we'll be getting one answer, and when you multiply that with y, you'll be getting this answer. Okay, plus z into the simplified value of this one. Okay, you'll be getting this value here. Okay. Okay, let me tell it in another word. Okay, what's happening here? 0 is there, 0 plus something, it will be this only. 0 will get cancelled out. So y x bar into y plus z. Okay, y x bar into y plus z plus z x plus y into y plus z. Z x plus y into y plus z. Okay, these two terms are present here. Now we'll be multiplying it internally and we'll be expanding it, and wherever it is common, we'll be taking it as common. Finally, we'll arrive at this equation. This is the simplified one. Okay. Moving on to the last super important question of this module, which is a digital system is to be designed. Of the month of the year is given. It is in the input form 4-bit. January is 0000, February is 0001, and so on. Output is corresponding to the input of the month containing 31 days. 31 days means the output should be 1, and if it is not 31 days, output should be 0. Consider excess number beyond 1011 as don't care. 1011 is 12, only 12 months are there. What about 13, 14, 15? This will be don't care. So okay, it will be x values. Okay, so write the SOP form and write the truth table first, then find out the SOP, then find out the POS, and simplify SOP using K-map and realize it using basic gates. Okay, so let's understand how this works. So see, January is 0000, February is 0001, March is 0010, and so on. Like that, we'll keep on writing. After December, it will be 11 here because we are starting from 0. It will come to 11. After this, 12, 13, 14, 15, this will be don't care values. Okay. Now the truth table is made. Based on this truth table, we'll be filling the values. Just make a table like this. Right here 00011110, 00011110. After that 0000. Check what is the value. 1. Right here 1. 0001. 0001. What is the value? 0. Right here 0. Like that, fill all these values. After you have filled all these values, form the groups. So the group will be formed. This one group, this is one group, this is another group. Okay, like that. Four groups we will get. Okay, we have to find out the SOP first, so we'll be taking the ones. Okay, and X also will be taken as one. Now we'll be writing these groups and finding out the values as same to the previous question where I had discussed the K map. Same way we'll be doing here also. We'll be getting one value here. Same thing we have to repeat for the POS also. Just take the zeros, make the group of zeros, and consider the axis as zeros wherever it is required. So the groups will be formed. This is one group, this is another group, this is another group. Three groups will be formed. Find out the similar ones based on that. So in the POS, what we do, when it is all one, we'll be taking a bar and we'll have to write plus, and for the zeros, we'll be writing it as such. Then combine these terms. Then this is the SOP and the POS form. Truth table is also done. Finding out the realizing using the basic gate. So here a bar d bar is there. Okay, so a bar d bar, so take a and d, put it through the NOT gate, so we'll get a bar and d bar. This is the AND operation, so a bar and d bar comes out from here. Next a b c, a b c you take, the first one is a bar, so pass it through the NOT gate and put it in the AND gate, and we're getting a bar b c, that will go here. Like that AD also, AD will take and put it here. All these three are connected with a plus, so this plus this plus this, like that. Okay, so that will be the final F equation. Same thing for the POS also. For the POS we have a plus d, a bar plus d. So a you take, make it a bar, and d you take here a bar plus d, that is OR gate. Here also OR gate you will be taking for this term, or the OR gate for this term. After these three OR gates are there, these are interconnected with an AND. So this will be this and this and this. Okay, that will be the F value. Okay, that's all from the module 1 DDCO. And if you like this video, please do like and subscribe. Don't miss any of these questions. And thank you so much for watching. I'll see you in the next one.